Okay, this is a review of your amount of substance test. So here's question 1. Nickel makes up 25% of the mass of 50 pence coin. 50 pence coin is 8 grams. What's meant by a mole? Definition you've just got to learn. It's equivalent to Avogadro's number of particles of a substance. Use the word particles here, so that way it covers anything, including atoms, molecules, ions, etc. Then calculate how many moles are in of nickel are in a 50 pence coin. First of all, you work out 25% of 8 grams because that's what it tells us up here, which gives us 2 grams. Then look up the relative atomic mass of nickel at 58.7 in the periodic table. Use the relationship moles equals mass divided by mR and get this answer 0.341 moles. Then it says calculate the number of atoms of nickel in 50 pence coin, so using this fraction of a mole. So how many atoms of nickel are there is this multiplied by Avogadro's number, which gives us 2.05 to the 22. On to question 2, and it gives us a lot of information here. The first part of the question says calculate the amount of moles in this 3.14 grams of ammonium sulfate. So you get 1 mark for calculating the mR of ammonium sulfate and 1 mark for recognising the relationship is moles equals mass over mR again. Plug in the 3.14 and the 132.1 and you get 0.0238 moles. Calculating the amount of sodium hydroxide, which is reactive, is looking at the mole ratio in the equation here. So you know for every 1 ammonium sulfate there are 2 sodium hydroxide, so multiply your answer to part 1 by 2 and that gets you 0.0475 moles. Then you've got to calculate the concentration of the sodium hydroxide, and this time you need to recall the relationship. Concentration is number of moles divided by volume. Number of moles is here and the volume's up here, but you've got to remember to convert that to cubic decimeters by dividing by 1000. Once you do that, you plug the numbers through and you get 1.21 moles. So continuing with question 2, part B says it's about this equation here again, and it's this time calculate the atom economy for the production of ammonia by this process. So recall atom economy. Percentage atom economy is the mR of the desired product, all added together, which is this bit, which is 34, 2 ammonias, divided by the mR of all the products, so that's the 2 ammonias, the sodium sulfate and the water. The 2 waters all added up is 212.1, multiplied by 100 gets you 16% for 2 marks. Then it gives you this, the Haber process, which is the way that you've seen ammonia manufactured from GCSE. The atom economy of this one's very straightforward to calculate because the only product is ammonia and it is the desired product. So the atom economy is 100%. And then this part gives you some information about the ammonia gas being produced. It gives you a volume in cubic meters, a temperature in degrees Celsius, and a pressure in kilopascals, and the gas constant. It's an ideal gas equation question, so you rearrange the ideal gas equation to get N, the number of moles, and you have to remember to convert everything to SI units. So 37 degrees C becomes 310 Kelvin, and 100 kilopascals becomes 100,000 pascals. Plug all those numbers through and you get 0.0594 moles. Then on to question E. It's about Glauber's salt. It tells you it's 44% by mass sodium sulfate, and that therefore in the hydrated form the other 55.9% must be the water, and we're trying to work out X in the formula of the hydrated salt. So you lay it out as an empirical formula question. There's your percentages, then you divide by the mR of sodium sulfate here and the mR of water here, 18, to get the mole ratios, which come out like this, and then you divide by the smallest, which is in this case 0.310, to both, and you get the whole number ratio 1 to 10, therefore x equals 10.